I'm Tim Ventura, and we're joined today by Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University. Avi is a theoretical physicist who works on astrophysics and cosmology, formerly the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. Among his many achievements, Avi is a best-selling author, has published over 700 papers and essays, made major contributions to scientific topics, including black holes and gravitational microlensing, and received recognition and awards from dozens of prestigious scientific organizations and academic institutions. So Avi, welcome back. Again, it is truly an honor. I can't thank you enough for your time today. So actually, before we got started, I have my questions list written out. But before we got started, I was talking about the fact that you are approaching the topic of UAP as well as Oumuamua and a lot of these emerging ideas from the context of 21st century science and technology, whereas a lot of the other material that I see out there is trying to kind of shoehorn it, I guess, into ideas that are really kind of stuck in the 20th century. So you were going to talk about that. So I wanted to kind of preface that for the audience.
Well, thank you so much for having me. We could have saved some time in the introduction if you refer to me as a farm boy. I grew up on a farm, and the reason I bring this up is because as a kid, I was very curious about the world, about nature. And one message we keep getting from the universe, but we don't pay attention to, is that we should be modest because our imagination is shaped by past knowledge, by experiences we had, whereas nature is much richer than we can imagine it to be. A century ago, no physicist imagined quantum mechanics, and now it's the foundation for all electronics, computers, internet, artificial intelligence, and so on. And so clearly that's a major shift that we had in the view we have of the universe as a result of observing it. It was not anticipated to start with, but we keep forgetting that. And, we started by thinking we're at the center of the universe. And then we said, okay, well, if we are not at the center of the universe, maybe we are the only sentient beings. And we keep holding to that. But my point of view is that of a kid. I want to see the evidence. And to me, it sounds more reasonable that we are not special, unique, or privileged, because every time we checked, we are not. A significant fraction of the sun-like stars have a planet the size of the Earth, roughly the same separation. So even our backyard is not particularly unusual. And I would guess that there were billions of forms of extraterrestrial life on other planets, exoplanets, and most of those predated us because most stars predated the sun by billions of years. And the only way to find out the truth about our cosmic neighborhood is to observe it, instead of having a prejudice and talking about it on social media. So what I came to the realization, that I should maintain my childhood curiosity and not pretend that I know more than I actually know, because I was really frustrated by the adults in the room when I grew up as a kid, and because I would ask a difficult question and they would pretend they know much more than they actually do. And that became apparent to me because once I looked more deeply into a question, I realized they don't know what they're talking about. And so the best way to learn is simply to collect data, evidence, not to believe that we can guess the answer in advance, because very often we are wrong. And that's pretty much the approach of a kid, as much as it sounds trivial. There is this story by Hans Christian Andersen about the child that said that the emperor has no clothes. And obviously adults often, subscribe to imagined stories, imagined realities, because they flatter their ego. And I say, let's observe the reality that we live in. And by the way, that is the language of science. Science should be based on evidence, not on wishful thinking, and not on partial data that is incomplete. And therefore people say, oh, this data is allowing for new physics. Well, that's not really the point. The point is not allowing for new physics. The point is showing that indeed there is no physics if you collect exquisite data. That's the scientific approach. And the best way to gain new knowledge is by gathering evidence. Now, I should say that, even within the scientific community, very often the fashionable themes represent past knowledge. And I met with 3 prospective PhD students just a couple of days ago. They came to my office and asked for career advice. And I told them that early on in their career, they should practice physics and learn physics from fundamental principles, because Picasso, when he started painting, he did it in a realistic style that represented the past. Once he mastered that, he started innovating with a disruptive style of cubism. And I think science should be done the same way. You first learn what's known. You can't just speak and say, oh, there is new physics, without actually knowing what actual physics is. A lot of people talk about new physics without knowing physics. So first you need to know what was provided by experiments so far. And that takes some years of studying. And after that, once you get tenure, that's the opportunity for you to innovate, to be disruptive. And that's pretty much what I'm doing now. I don't care how many likes I get within academia or outside of academia. I'm just trying to attend to evidence. So when there is an unusual object, if that object does not have cometary tail, I say, this is not a comet, just like the kid said. The emperor has no clothes. There is the clothes here are the cometary tail. And so the question is, what is it? It was really peculiar. Just to contrast that with the approach that my colleagues take, I can mention that 6 months ago, there was a colleague of mine that said, I just wrote a review paper in a very prestigious journal about Oumuamua. This object didn't have a cometary tail, behaved in a very strange way, and it was pushed away from the sun by some mysterious force. And he said, I wrote a review paper about the comet Oumuamua. And I said, what do you mean by the comet Oumuamua? That's an oxymoron, because it was not a comet. And he said, well, I have this theory that when we didn't look at it, it had a cometary tail. And I said, this is just like going to the zoo and looking at an elephant and saying that's a zebra and it shows its stripes when you look away from it.
Yeah.
So I'm saying there is a lot of that in academia. There is a lot of that in the general public. And as always, maintaining what sounds like common sense is not common. And that's the middle ground. And we should be guided by evidence.
Absolutely. Well, so I want to jump into your new paper. This is really exciting. This was, in fact, I've just seen the draft copy of it. Physical Constraints on Unidentified Aerial Phenomena, with co-author Dr. Sean Kirkpatrick, who is the current serving director of the All-Domain Anomaly Resolution Office. So let me ask, how did this collaboration come about?
Well, Sean wrote an email to me and said that he's visiting the area, and I invited him to my home for a conversation. And during that conversation, he suggested that I write a paper, scientific paper about UAP. As you know, I established the Galileo project that is fully funded, and we built an observatory. We're starting to collect data, but we don't have yet results because we are still testing the system. Okay, so I couldn't write a scientific paper on that data that we are collecting, but I thought of writing on the constraints that physics puts on any object moving in the sky. And at some point, I asked him if he wants to be a co-author, and he said, sure. And so we wrote this up, and this is just a draft that I placed on my website. And as I do often with papers, before I submit them to publication, I mentioned it in one of my commentaries on Medium. And this is in order to get some feedback if people have some reservations or comments about it on the science. And it became viral. I didn't anticipate that. Now, it's still being reviewed. It's not submitted for publication yet. So it's a draft. But basically, what it's about is setting constraints when the data is incomplete, when you don't know, for example, the distance to an unidentified object in the sky, you can place constraint that the object cannot be too far away, because as it moves across the sky, it would need to move at a very high speed. And as a result, it would create a fireball in the atmosphere just because of its high speed. And if you don't see that, it means that it's closer to us. And also it hits the air, and so there should be some radar signature of that. And so we were talking just about what conventional physics can say about objects moving in the sky.
Yeah, well, I think the reason that it went viral, I think the reason people are so excited, definitely my hope, I guess, is, in the past, government investigations, right, ATIP and at least so far AARO, have been rather closed, right? They've been apart from the public. And part of that is because some of what they're working with is classified material. It reveals vulnerabilities, it reveals things about our defense, structure that we don't want public. But I think part of that also is just so that they can focus and avoid things potentially turning into a circus. So I think what's so exciting about this paper is we're seeing what hopefully is the beginning of some kind of an open collaborative effort between, real, valid, credible, ongoing government investigations and subject matter experts like yourself in academia, and that's absolutely wonderful. To me, it seems like that just benefits everyone and helps move the truth forward.
I completely agree. And I think that scientists are complementary to government. Government is interested in national security concerns. They want to protect the safety of the nation, the safety of military personnel. And frankly, I don't really care on human-made objects in the sky. I will be glad to transfer any such data to any organization in DC. I also do not care much about birds or bugs, natural objects in the sky. I would be glad to transfer that data to a zoologist. I really care about the technological objects that came from outside of this Earth, okay? And in that sense, it's sufficient to have one object for this to change the future of humanity. Now, in this paper, we're talking about speculative possibilities.
Yeah.
He asked me, what would you conceive as possibilities? And we lay them out. And also we use standard physics to examine constraints. So frankly, I was not really sure that there is a point in getting this paper out, because it doesn't bring any new data to the limelight. As I said before, we should be guided by data. This is pretty much still in the realm of possibilities and constraints. That's what this paper is about. But as you say, it opens a conversation. And because the effort from the government is complementary to the scientific interests, I think we can, in principle, collaborate, because within the Galileo project, we developed expertise in terms of how to calibrate instruments that look at the sky, and what kind of instruments are best to use, and what's the algorithms that one can develop to analyze the data so that we can classify the objects into natural or human-made. And in principle, any expertise we develop from a scientific standpoint, if it's of help to the government in shooting down balloons, I would be happy about it, because these balloons are basically noise as far as I'm concerned.
Yeah.
So the more they shoot down, the less there are in the sky, the easier it is to see if there is anything else. So I'm happy the government will take away all the objects that are of national security concern, because I'm interested in the rest. Okay. And in principle, we can work together. I'll be glad to help government, with the expertise that we develop, with the data that we don't care about. And at the same time, if they see an object from an extraterrestrial origin, because they have a very high resolution image and it doesn't look like a human-made object, doesn't look like natural object from Earth, I don't think it's the privilege of the President of the United States to know about it. I think all humans should know about it, because any such object started its journey a long time ago, before humanity came to exist. It takes light 50,000 years to cross the disk of stars in the Milky Way galaxy. 50,000 years. We were not that interesting back then, 50,000 years ago, because we were in caves, indistinguishable from nature. And that is at the speed of light. If you launch probes that move at the speed of all the chemical rockets that we've used so far, it will take 500 million years to traverse the Milky Way galaxy. So whoever sent probes did not have us in mind. That's my point. And therefore, national borders are irrelevant. Okay.
Well,
and yeah.
Yeah, so I wanted to kind of get into the paper a little bit too. And so again, it kind of begins to some degree, starting to talk about Oumuamua again, with the hypothesis that this is an artificial interstellar object, right? And so what makes this unique is, again, I think a lot of people are familiar with that. It's been described in fiction, something very similar in Arthur C. Clarke's Rendezvous with Rama novel, right? Back in, I think, 1973. So,
by the way, a comment on that. I want to separate science from fiction. So when, even if someone imagined something, science is here to testify whether this thing exists, because there are so many things we can imagine. So indeed, it shows the genius of Arthur C. Clarke that he could have conceived of a scenario not very different from Oumuamua. Yes.
Well, and it's intriguing too. In Rama, it was a cylindrical, definitely spacecraft looking, absolutely artificial device, right? And with Oumuamua, it seems like they'd said that it was kind of a reddish in color, which could suggest that it was similar to, some of the rocky parts of the outer solar system. But what interested me about that was I thought, you would really want to surround an interstellar vehicle with something heavy to shield it from galactic radiation, right? So it's entirely plausible that this, even if it is rocky on the outside, lacking a cometary tail, as you've mentioned, having some anomalous movement, acceleration from the sun, as you've mentioned. I mean, these things, there's definitely mystery there, right?
Yeah, well, the best fit to the variation of reflected sunlight from the object indicated at the 90% confidence that it's flat. It's actually not cigar-shaped. But there was another object 3 years later discovered by the same telescope in Hawaii, Pan-STARRS. It was given the name 2020 SO because it was discovered in the year 2020, September 2020. And within a few weeks, the astronomers realized this object is pushed by reflection of sunlight, the same argument that I made for Oumuamua. And moreover, it has no cometary tail. And then they realized, if we go back in time, it actually came from Earth. It's a rocket booster from 1966, and it's made of stainless steel. They could verify that. So here is a technological object that we produced. The question is, who produced Oumuamua?
Yeah. Well, so in the paper, one of the things that takes it kind of a step farther out, I guess, is the hypothesis or the idea, right? And not as a statement of fact, but as an idea. What if it is connected to UAP? The UAP could be basically probes that are released from it. And so this could potentially, it could be traveling from system to system, planet to planet. Potentially it could be using a gravity assist around the sun. I mean, there are a lot of different, what ifs involved. And in this paper, yourself and Dr. Kirkpatrick asked, what if the UAP are actually probes, potentially even von Neumann probes that are released from it, right? I believe you described them as almost like dandelion seeds.
Yeah, and the reason I started thinking in this direction actually before the visit of Sean is that there were two meteors that came from interstellar space that we discovered with my student. One of them from 2014 and the second from March 2017, both before Oumuamua. But the 2017 one actually came exactly to the same distance of closest approach from the sun as Oumuamua. It came 7 months earlier, and it had the same speed as Oumuamua. So I immediately wanted to check if it may be associated, because you could imagine Oumuamua sending a tiny probe that comes to Earth, right? And turns out that it didn't come from the right direction. So it could not have been associated with Oumuamua, but nevertheless, you can imagine a scenario where you have a mothership that moves too fast to slow down and park on a planet, a habitable planet. So it releases a lot of small probes to the planets in the habitable zone. And of course, one reason to pass through the habitable zone is because there is liquid water, there are nutrients that can be used as fuel. You can charge the batteries of whatever device you have. So the question is, could it be that some UAP are probes of this type? And the scenario is that if they come close to Earth, they might use a parachute in order to slow down in the atmosphere, not burn up like a meteor. And then they can pursue whatever goals they have. And the question is, what would they try? What are they seeking? And of course, one possibility is von Neumann probes that John von Neumann thought about in 1950, 73 years ago. And it's amazing because he thought about it before the DNA was discovered. And it turns out nature is using exactly this idea that he thought of, whereby, like, as you mentioned, dandelion seeds, a flower sends seeds and they carry the DNA and maintain the genetic information of the flower so that, wherever they land, and by the way, they also have some kind of a small parachute in the air and they land and then you get the same flower. So you get multiple generations. And if there was a civilization that wanted to sort of replicate its DNA in the way that von Neumann thought, that one approach is to send these dandelion seeds through many solar-like systems and plant those seeds on the habitable planets in them for whatever reason. I mean, we don't know what the reason is. Now, of course, the way to figure out if we live in such a reality is to look up and search for unusual objects, functioning probes. But it's also possible that there is a lot of space trash. That's another category, because we sent Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons, 5 probes in about 50 years that are making their way to interstellar space. And if you imagine ourselves, like 1,000 years from now, if we survive, we will send plenty of probes to interstellar space. And I calculated that if instead of fighting each other and spending $2 trillion on military budgets every year worldwide, if we were to dedicate the $2 trillion a year to space exploration, then within a few decades, you can basically send a probe from Earth to every star in the Milky Way galaxy. And just think about it, just a matter of several decades for a peaceful civilization. And all we need to do is listen to the words of John Lennon's song, Imagine All the People Living in Peace.
Absolutely. Well, I want to touch on, again, going into the von Neumann probe thing. For people who think, wow, this is a really far-fetched idea, right? Self-replicating, AI-driven robot probes. I recently did an interview with Dr. Gary Nolan, and he is an advisor to the Copernicus Initiative, which is a project that you've started to do exactly that, right? And what he had said in the interview was, you're looking at different ways to explore Mars and the asteroid belt, and how could these probes potentially find ways to self-replicate and basically use exponential doubling to do what manufacturing here on Earth could never achieve.
Exactly. In the past, space missions focused on big payloads, like once a decade, sending a very big spacecraft. It may be much better to send a mothership that releases a lot of probes, because then you don't visit just one geographical location on Mars the way we are doing right now, but you can spread them all around Mars if you want to check different environments on Mars, or even going beyond the solar system. So we founded the Copernicus Space Corporation with Dr. Frank Laukian and myself as a a venture. So that's a commercial entity. It's not a scientific research project. And we have an exceptional scientific board. And Professor Nolan is a member of that board. And indeed, as you mentioned, we are trying to make it real for our civilization, this approach. And if we can imagine it, someone else may have done that, because most stars formed billions of years before the sun. So the Galileo project is engaged in checking whether others did it. The Copernicus mission is more about us doing what we can imagine. And the reason we called it Copernicus is because it could lead to the next Copernican revolution in space exploration. Absolutely.
Well, Avi, let me thank you for your time today. And let me close by asking, how can people get involved? There's the Galileo project, and you have been diligently working on that. It's picking up steam. Now there is the Copernicus Initiative, right? Which is, again, looking at ways to begin exploring other planets using some of the same strategies that could potentially be used in the UAP phenomena. So there are a lot of different things that you're involved with at the moment. Where should people go? How can they get involved, and how can they help?
Well, they can reach out to me. We do have on the Galileo project website a form that can be filled by whoever is interested in joining the team. But anyone is welcome to approach me and specify the expertise that they can bring to the projects. And I think the coming years will be very exciting. It's really up to us, to make them exciting. And by this summer, we are going on an expedition to retrieve the first interstellar meteor, the fragments from it, and figure out their composition, because apparently it was tougher than iron, tougher than all previous space rocks. That's the meteor from 2014. And if we find that it's made of an artificial alloy that was manufactured by another civilization, that will obviously be an important breakthrough. So on all fronts, unidentified aerial phenomena or interstellar meteors or the next Oumuamua, there is an opportunity here to harvest low-hanging fruits, because nobody took that approach in the past, scientifically speaking.
Absolutely. Avi, thank you again so much for your time today, sir.
Thanks for having me.